Hello, my name is Omer, and today me and my team will be presenting the role of system calls and secure process management. For introduction, to introduce this topic, modern operating system use a clear separation between user mode and kernel mode to keep the system secure. Since applications can't directly access hardware or sensitive memory, they have to go through system calls which act like a control gateway into the kernel. Because every important interaction passes through these calls, they play a major role in how processes are isolated and how actively is monitored and how privileges are managed. That's why understanding system calls is essential for understanding secure process management. Uh, and here I will be explaining how the operating system is structured in terms of privilege levels. We have user mode where regular applications run with limited permissions, and this help prevent them from accidentally harming the system. Then we have kernel mode, which has full control over hardware memory and all critical resources. The kernel is responsible for scheduling processes, handling memory, managing devices, and enforcing security rules. This separation creates a strong security boundary that keeps application isolated from the core of the system. What are system calls? System calls are basically the way user program communicates with the operating system. Since applications can't access hardware or kernel memory directly, they use system calls as a safe and controlled entry point. Through system calls, the OS, the operating system, handles things like creating processes, reading and writing files, managing memory, and even network communication. Before any system calls is executed, the kernel checks that it is valid and that the process has permission to do it, which is why system calls are so important for maintaining security. I'm sorry. Next, we have the access control. It is one of the main security roles of system calls. Whenever a process tries to access a file, allocate memory, or even open a network connection, the system call layer checks whether that process actually has permission to do it. The kernel looks at things like ownership, group identity, and capability sets to make sure that processes stays within its allowed boundaries. So overall, system calls act like security guards, making sure each process only accesses what's authorized to use. Next, we have process isolation. It is one of the most important security features in an operating system. It basically means that one process shouldn't be able to read or modify another process's memory or resources. System call help enforce this boundary, and any operation that could break isolation, like using trace, is heavily restricted and requires special permission. By keeping processes separated, the system prevents attackers from escalating privileges and protects sensitive data inside the system. System calls give us a clear picture of what process is doing, so they are really useful for monitoring. Tools like Trace or Audited track system call activity to spot anything unusual or potentially malicious. By analyzing patterns in these calls, security teams can identify things like malware behavior, suspicious access attempts, or signs of an intrusion. intrusion. So system calls aren't just functional; they are also a key source of insight for forensic investigation. Uh, Process creation and termination. The operating system relies on system calls for both creating and ending processes. Whenever a new process is needed, like fork, clone, are used to either duplicate a process or load a completely new program, and the kernel makes sure that the new process only inherits safe attributes. On the other side, ending a process also depends on system calls like kill, but the system will only allow it if the calling process has the right permission. So overall, system calls control the entire life cycle of a process from start to finish. And my teammate will be taken over from here. Thank you.
Hey there, my name is Muhammed Abbas. My student number is 220208928. I'm gonna follow my friend with the next part, which is context switching. Context switching allows a CPU to move between multiple running processes. The kernel saves and restores important information such as register context, memory states, and prevalent levels. System calls the influence, scheduling, or process priority must be validated to prevent noises, such as a process attempting to gain unfair CPU access. Secure context switching maintains fairness, stability, and strict separation between process and environment. So that was all for the context switching. Now we're gonna go to the prevailing previous escalation. We starting with one of the most critical security goals is preventing unauthorized evaluation of privileges. System calls such as an student and capacity and strictly validated to ensure that the process cannot gain higher privileges than they are allowed. So modern operating system implement additional protections including Linux capabilities and namespaces and secure environment variables handing to reduce the escalation risks. So yeah, moving to the next part, system calls injections. So system call injections occurs occurs when an attacker manipulates a program into an existing system. Calls that were not intended by the developers. So if this is got archived through methods such as code injections, return operating programming, or modifying internal system call handling structures. So if it's successful, the attackers might gain unharmonized access to the kernel functions, and it will be leading to serve system compromise. So yeah, and for my last part, TQ raises conditions a time of check or to time of using vulnerability appears when restores when resource is validated for safety, but it is altered before it is used by the kernel. This type of vulnerability appears commonly in file system operation involving symbolic links or shared memory. Dictio dictio false can cause privilege escalation, data cooperation, and incorrect programming behavior if the system acts on outdated assumption. Careful synchronization and validation are necessary to prevent those attacks. So yeah, that's all my part for now. And my friend is gonna be following you with the third part, which is the final part. Thank you for listening.
Kernel vulnerabilities, it's basically an improper handling of system call inputs that can expose the kernel to buffer overflows, which is pretty self-explanatory. It contains overflows, memory corruption, and resource mismanagement because the kernel operates at the highest privilege level. Any vulnerability within it can compromise the entire system just by itself. Proper input validation and secure coding practices within the kernel are very important and essential to prevent high-impact vulnerabilities. On to the next point, which is system call filtering. System call filtering is a powerful technique for limiting what actions a process is allowed to perform. Technologies such as CComp BPF, CSE Linux, AppArmor, and extended Berkeley packet filters enforce restrictions on which system calls a process can use, by reducing the system calls to only those needed by an application. The attack surface becomes significantly smaller. This is one of the most effective hardening techniques for modern software environments. Now on to the case studies, which involves everything we spoke about in the previous slide, me and my partners. Practical examples demonstrate the importance of system call security and Container platforms such as Docker rely heavily on system call filtering to isolate applications from the host operating system. Major vulnerabilities like Dirty Cow, Spectre reveal how flaws in kernel behavior or system call handling can lead to severe consequences. System call activity is also crucial in forensic investigations where abnormal patterns may indicate malicious activity. Now on to the conclusion and the end of this chapter. System calls form the backbone. It forms the backbone of secure process management by controlling how user-level applications interact with the kernel. They maintain access control, enforce process isolation, support monitoring and auditing. And also it prevents unauthorized privilege escalation. Strengthening the system call filtering, validation, and monitoring is essential for protecting modern operating system from evolving threats. Thank you so much for listening to us, and I hope you enjoyed.